Okay, so we have one more fact, and so this is 2.3b continued. And we have one more fact, which our book calls Theorem 7. And you do not need to know that it's called Theorem 7, except there's one homework problem that mentions Theorem 7. So I didn't want you to be confused when it mentioned the theorem. But this is just our book that calls it this. So don't memorize that this is Theorem 7. So anyway, what Theorem 7 says is if f and g are continuous, so just like yesterday, we have two separate functions that are continuous. One of them is called f, and one of them is called g. And we wrote down a bunch of things that happen yesterday. F plus g is continuous, f minus g is continuous, f times g is continuous, et cetera, et cetera. But there's something else that's continuous if f and g are continuous. What's continuous is this function, f of g. And you saw this on the homework that was due yesterday, but I just want to make sure you know, this means the composition. This means f of g of x. And remember, that means take the function g and plug it into f. That's called composition. Okay, so if f and g are continuous, then the function f of g is also continuous. So now we have a bunch of facts that we can use to figure out if functions are continuous, rather than just looking at the graph or using that official definition. Okay, so I think I did one problem yesterday, so I think this would be example 2. So we're going to have h of x equal the function sine of x squared over x squared plus 4. And for part A, we're going to decompose. Sounds kind of gross, but it's not. We're going to decompose h into two functions, f and g, and then find f of g of 2. That's for part A. So we have this function h. And we're going to first decompose it into two functions, f and g, and then we're going to find f of g of 2. Okay, so if we're going to decompose it into two functions, that means we need to pick an f of x, and we also need to pick a g of x. And g of x is the inside function, and f of x is the outside function. Okay, so if I look at this function h, I think inside is x squared over x squared plus 4, and then sine is happening to that. So I'm going to pick my g to be x squared over x squared plus 4. And then I'm going to pick my f to be sine of x. So now I've got two separate functions. And if I plug this function into that one, then I end up with h. So that's called decomposing. This is the composition, and this is the decomposition. That's not the only way to do it, though. So that's one possible answer. Let's see if we can come up with another answer for decomposing this. can do this. Don't give up. Maybe not. Okay, I guess I'll tell you. How about this? So if you stick x squared there and there, then you get that, right? Okay, then I've got a really obnoxious answer for you. That's pretty obnoxious. If you stick this here, you get that, right? Is everybody okay? Okay, so I gave you 3 answers. Here's one of them. Here's another one. Here's a third one. Okay, so that's for first part. That said decompose h into 2 functions f and g. Okay, then for the second part, we have to find f of g of 2. So I'm just going to do this one. So f of g of 2 is another way to write that. This and this are the exact same thing. And this means plug 2 into g first. So if you plug 2 into g, you're going to get 4 divided by 8. So 1/2. And then what you do is you take your answer and you plug it into f. So you take 1/2 and plug it into sine of x. So that's going to be the sine of 1/2, which is some nasty decimal. So I'm just going to leave the final answer as sine of 1/2. Okay, so that was part A. Now for part B, we are going to show that h is continuous. Okay, so first of all, x squared is a continuous function. So how do I know that x squared is continuous? Because it's a polynomial. Good. Okay, then also x squared plus 4 is continuous. That's also a polynomial. So I have 2 separate functions that are continuous. So if I divide them out, I'm going to get another continuous function. So I have this function that's continuous because it's polynomial, and that function that's continuous because it's polynomial. And yesterday we said if you have 2 separate functions that are continuous and you divide them, then you get a third function that's continuous. So that's why this one is continuous. Now division doesn't always work, right? So I have to be a little bit careful. When wouldn't division work? Yeah. If the bottom came out to 0, right? But x squared plus 4, it can't possibly come out to 0. The smallest x squared can be is 0. Because if you square a negative number, it's going to be positive. So the smallest that can be is 0. And if I take 0 plus 4, so the smallest that can be is 4. So this is continuous since x squared plus 4 can never be 0. So you have to be a little bit careful with the division rule. Yes? I'm not there yet. So you are correct. I have not answered the final question yet. Because the final question is, show that h is continuous. And so far, I've only shown that that's continuous. So I do have to show that this is continuous still. So good point. I'm not quite done. Okay, but so far, I know that this function is continuous. Okay, then also, f of x equal to the sine of x is continuous. And I'm going to allow us to use a graph argument for this. So if you look, usually you're not allowed to use a graph argument and just say, oh, it's continuous because it's connected. But in the middle of this problem, I'm going to let us slide on that a little bit. So if you look at the graph of sine, it's a nice wave that's connected, right? So that's why sine of x is continuous. So I'm not really big on informal arguments, but in this one line, I'm going to let us get away with it. Okay, so I have f of x that's continuous, and I have g of x that's continuous. And then I have this fact over here, which the book calls Theorem 7, that says if I have the inside function continuous and I have the outside function continuous, then the composition is continuous. So now, since I have these separately, so by Theorem 7, f of g of x, which is equal to h of x, is also continuous. Is that making sense to everybody? Yes, Lauren. Well, where the denominator equals 0 is definitely where you suspect it's not going to be continuous. Yes, that's right. Yeah, and so then after you figure out when the denominator is 0, you calculate the limit there and the function value. And then if those don't match up, then you know it's not continuous. But you're right, it's good to suspect division by 0. But you wouldn't necessarily be done then. Yeah, good question. But then on this one, the reason I knew that there weren't any problems is because the denominator is never 0. Good. Great question. All right, everybody else good with this? Okay. I think I'm pretty much close to being done. I decided to do 2.3b in 2 days so that we could kind of get used to being at school here. Yeah, that's it for 2.3b, so that's nice because that gives you a half an hour. One warning I want to give you